Hey guys, this looks like a fun one. We have three semicircles all touching each other, and we're given the diameters of the smaller two, and we're trying to find the diameter of the largest one. I think it's safe to assume that the yellow semicircle is tangent to this red one right here, and tangent to this diameter right here. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First thing, just visually, we can drag this down here, and it looks like it's just going to be this diameter plus this diameter. So my initial guess is question mark equals 5. If not, I think it's going to be very close to 5. So how are we going to find out exactly what it is? First step, I'm thinking let's break these diameters into radii. So if we find the center here, a diameter of 2 will give us 2 radii of 1. And then if we find the center here, this diameter of 3 is going to give us 2 radii of 1.5. Usually at this point, we want to swing both these radii to meet at this point of tangency. I've done this a couple times and I always get a question, how do we know these are the same line? So let's talk about that. These two semicircles touch in one point and this tangent line touches both of them at that one point. And we can swing this radius here, and a radius at the point of tangency always meets at right angles to the tangent line. And the same thing down here, this will also meet this at right angles. Since these two radii are perpendicular to the same line, that means they're parallel to each other. And then we know both of these parallel lines go through that same point of tangency. So anytime you have two parallel lines that go through the same point, that makes them the same line. So that is how we know these lie on the same line. Next, we can swing this radius down here, and it's going to be at right angles to this tangent line. And now we've got a nice looking right triangle. On the hypotenuse, the 1 and the 1.5 can combine to give us 2.5. Now let's call the unknown side x. Now we're ready for Pythagorean theorem. We know that x squared plus 1.5 squared is going to be 2.5 squared. We can bring down the x squared. 1.5 squared is 2.25, and 2.5 squared is 6.25. After we subtract 2.25 from both sides, we get x squared is equal to 4. And then we can square root both sides, and we get x is equal to 2. So we can change this side length of x into 2. We're not going to need this work anymore, and let's bring back our original diagram. So now we know that the distance from here to here is equal to 3. We still need to find this remaining piece. Next, from this point right here, let's drop a perpendicular line to this diameter. This is the same length as this right here, so that'll also be 1.5. And then this radius right here is also 1.5, and we can drag it down here to see that this piece is 1.5. So now we're really getting close. We just got to find this last portion right here. Let's call the unknown value y. And I think I see how to solve y. I don't think we're going to need this triangle anymore. From this point right here, let's connect it to here, and let's connect it to here. This larger angle we just created will be a right angle. And we know it's a right angle because the legs are on the diameter, and an inscribed angle with the legs on the diameter is always a right angle. Next, let's focus on this giant triangle we just created. This piece right here is made up of the 1, the 2, and the 1.5. The sum of these will be 4.5. And then let's call this angle theta. We know this angle up here will also be theta. And it might not be obvious why this angle is also theta, so let's talk about that for a sec. This large triangle and this little triangle have a shared angle right here. Let's call it alpha. Now let's make a copy of the large triangle and focus on the small triangle. The large triangle has an alpha and a right angle, and the last angle is theta. Well, the small triangle also has an alpha and a right angle, so the last angle would have to be theta. So that is how we know the little angle is theta. And this alpha, we're not going to need it anymore. I just used it to show the theta. I kind of want to leave this alone, so let's duplicate it. Now from here, I want to break apart this little triangle and this medium-sized triangle. So let's label this as a right angle, and let's get rid of this right angle label. And now we're ready to break apart the triangles. And we can rotate this so their orientations are the same. These two triangles are similar, so we can set up a proportion. We can say that the bottom divided by the bottom equals the side divided by the side. So it would be 4.5 divided by 1.5 equals 1.5 divided by y. Next, we can cross multiply. 4.5 times y is 4.5y, and 1.5 times 1.5 is 2.25. Then to solve for y, we can divide both sides by 4.5. That'll give us y is equal to 0.5. Let's clean things up and bring this up here. And let's return to our original diagram. We're now ready to update this last unknown portion. We can change the y into 0.5. And we now have everything we need to solve for the question mark. The question mark is equal to 4.5 plus 0.5. And 4.5 plus 0.5 is equal to 5. Let's give it a label of units and put a box around it. So it turns out the initial estimate of 5 was correct. How exciting.